Iron plays a key role in the modern world. Imagine a world without iron. There would be no large constructions or buildings. No forms of transportation. Many tools would have never been developed. And most importantly, Popeye will remain just a sailor. Actually, without iron, on our planet, life as we know it would not be possible. Moreover, there are various forms of life that depend on iron as a sole energy source. An example of these forms of life can be found on the bottom of this well. In order to create the free energy required, the microorganism takes up ferrous iron and oxidizes it to ferric iron. Since most microorganisms survive in environments with neutral pH, the reaction actually looks like this. What immediately stands out is that the product is a solid. There are a few problems with these reactions. First of all, the product, in contrast to the substrate, precipitates. If the toxic ferric iron is not dealt with, it will accumulate and kill the microorganism. Over time, the microorganism has developed inventive ways to eliminate this problem. A first example is the excretion of the ferric oxides in the form of a stalk. The formation is linear with cell growth. Another way is the creation of nests of iron oxides. The cells encapsulate the toxic ferric oxides to protect the cell from harm. A second problem is that the free ferrous iron is sometimes not available and it needs to be acquired in other forms. The ferrous iron can be harder to obtain because it's stuck in the form of minerals or through ligand binding. The last major problem is the concentration of oxygen. A high concentration of oxygen will result in a super fast conversion to ferric iron. The reaction is too fast for the organism to obtain the energy gained. When the oxygen concentration is low, this reaction speed is reduced. So how does nature match these requirements? Of course, the habitat. There are actually many forms of habitats which meet these requirements. Iron oxidizing bacteria can be found on the bottom of marine environments, but also on the bottom of freshwater environments. Furthermore, iron oxidizing bacteria can also be found in places not flooded with water, like the wall of an iron mine, and more. The biodiversity among these environments is huge, and the bacteria do not seem to be genetically related. In conclusion, iron oxidizing bacteria have developed independently in various environments, supporting the hypothesis that the environment plays the key role in their large biodiversity.
Created using PowToon.